Welcome back. Now we're ready to have some fun. In this module, we're going to actually start some operations of radical expressions. Today we're going to talk about adding and subtracting radicals. And the great thing about algebra is rules don't change. Even though your terms may look weird or different, the rule is the rule. And we've discussed this already since kindergarten. You can only add terms that are alike. You can only add an apple to an apple, an orange to an orange. We've learned in polynomial world, you can only add variables that are alike. You can only add an x to an x, a y to a y. We learned in fraction world, rational world, we can only add fractions that have a common denominator to show that they're alike. So in radical world, we're going to have terms that are alike. What's going to make the terms alike in radical world is the radicands. First of all, we're going to have to be dealing with the same root. There's no way to add a square root to a cube root. Let's get that said right now. When I ask you to add radical expressions, I'm asking you to add a square root to a square root or a cube root to a cube root. But what's important is the radicand has to be identical. Think back to the beginning of this course. If I asked you to add 4x and 5x, could you do it? Yeah, because those are like terms. They have the identical variable x. And what you really did is just add the coefficients. I have 4 X-ray machines. You have 5 X-ray machines. We add them up, we get 9 X-ray machines. And that's why 4x plus 5x was 9x. Well, the same thing's true here in radical world. If I have 4 square roots of x and I want to add to that 5 square roots of x, the first thing I got to check that my radicands are exactly alike. And they are. They're both square root of x. So what we're really doing is adding the coefficients. 4 plus 5 is 9 square roots x. Now, one thing you have to be careful of is because we're dealing with radical signs, whatever's underneath that radical has to be in lowest terms. It has to be reduced. Just like when we're adding and subtracting fractions. After we added our fractions or subtracted them, then we had to make sure our final fraction was reduced, simplified. So that's the hard part of this module. After I add my 4 square roots of x and my 5 square roots of x and I get my 9 square roots of x, is my square root of x in lowest terms? And the question is yes. X has an invisible exponent of 1, and the square root, you must have an even exponent, and there's no way x is in lowest terms. It's prime. So that answer is, that sum is 4 square roots of x. Look at my next expression. 12 cube roots 8 minus 7 cube roots 8. So what operation am I asking you to do? That's right, I'm asking you to subtract. To add and subtract, you must have like terms. In a radical world, the radicands have to be identical. All my radicands identical. Yes, I have a cube root of 8 and a cube root of 8, which means I can put these terms together by subtracting. I just have to work with the coefficients. So 12 cube roots 8 minus 7 cube roots 8 would be 5 cube roots 8. Do you all agree? Great. But that's not the final answer, because now look underneath your root symbol. You have a cube root of 8, and what do you all know about 8? That's right, it's a perfect cube. What is the cube root of 8, everybody? It's 2. So now that expression just becomes 5 times 2, which is 10. So the adding and subtracting are not difficult. You're just making sure you have like terms. The radicands are the same. The hard part comes when you have to make sure your answer is completely simplified. All right, let's try some on the whiteboard.